Hello and welcome back to the channel. Today we're going to do Advent of Code 2015 day 8. A bit of string escaping. Actually wasn't that hard. Had some trouble with regexes. But first let's look at the problem description. Apparently Santa is sick of the analog world and wants to digitalize as well. So instead of writing everything down by hand, he now has a digital list. And that list consists of several strings. What he wants to know now is how much space the list will take up. So the topic for today is how to escape strings, or what it actually means to escape strings. So first we need to understand how we escape strings and why we actually do it. Looking at the example here, we see there's a variable greeting and we assign a string hello playground to greeting. The compiler knows it's a string because we started with a double quote and ended with a double quote. Now, what do we do if we want to add a quote inside the string? If we just finish with another quote, the compiler will complain because there are now consecutive statements on one line and it doesn't know what to do. What we need to do now is escape the character, and we do that by a backslash. With that backslash, we tell the compiler, don't use the next character as a special character, but take it literally. So now we would have a string hello playground with a quote in between. Same happens if we want to do a backslash itself. We need to do two backslashes. If we only add one backslash to it, the compiler will complain as well. So for Santa's problem, there are three different escape mechanisms. So one will escape the backslash, as I've shown before. Another one will escape a quote. There's one special thing. So if you have a backslash and an X, the next two characters will be the hexadecimal number of an ASCII character, and thus will be replaced. So for example, if we have backslash X 40, that will be an add. Same if we had backslash 41, that would actually be an A. So what we need to do now is to calculate the difference between the strings having all of the escape sequences and the string without all these escape sequences. In the examples it says an empty string is just two quotation marks, so it has two characters of code, but there's nothing in it, it's an empty string, right? Same for ABC. ABC is 3 characters plus the 2 quotes, so it's 5, but actually the string is only 3 characters long. And for the backslash, if we take the string AAA backslash AAA, it's just 7 characters, but in code it's 10 because we have 2 quotes and the backslash for escaping. And the more difficult one is the last one. So we have backslash X27, which is an apostrophe. So it's 1 character, but in code it's 6, 2 double quotes, backslash X and 27. So actually I kind of struggled today because I tried to solve it with regexes, and as I said, I'm not that good with regexes, but I actually think those regexes were correct. And then there was one special case that I'm going to talk about in a minute. But first, what I did to actually solve the problem was just doing it by hand. So I'll just go over it quickly because that's not the best solution I came up with, but it's a solution that worked. So I just want to show you how I solved it first. Then in the next step, a better version after refactoring. I iterate over the input, which is just the strings and then separated by new lines. Basically, I go over the whole string character by character. I check if the character I'm currently looking at is actually a backslash. If not, we can continue because we're not escaping anything. If it is a backslash, there are different things we need to check. So if the next character is also a backslash, or if it's a quote, it means we're either escaping a backslash or a quote. So we just append either the backslash or the quote after it and then skip the next character. If it's not an X, just continue as above. Now we need to make sure that we're not getting out of bounds with our index, and then check the next 2 characters after the X. If those are actually numbers or characters, we also remove it. And as I see right now, there's actually a bug in it, because if they weren't, I wouldn't do anything and we would be stuck here indefinitely. But apparently there's no false formatted input. And what's important now is that we skip the next 3 characters, so that's how we remove it in here. So that's nothing I actually like. So I went back and tried to solve it with regexes, and now what I came up with is basically just that code. So we have a regex for backslashes, which is just escaping a backslash and then the backslash, escaping a backslash and then a backslash, which actually means if there are 2 backslashes. And we have the quote regex, so a backslash followed by a quote. And then we have the hex regex, so a backslash, an X, and then 2 characters or numbers. What we then do is we just map what we have by replacing the backslash regex with an underscore, the quotes regex with a quote, and the hex regex with an add. That part is actually quite important, and I'll show you why in a second. What we then do is we just count the characters of each string. We subtract 2 because each string starts with quote and ends with quote, and that's nothing we're interested in. And then we just sum up all the digits we have. We do the same thing for the original input, that time not subtracting 2 because now we actually need to count the quotes, sum that up as well, and then just calculate the difference. So our result in that case is 1333. As I mentioned, it's actually quite important that we do it that way, because what I did in the beginning was replacing it by the values they actually represent, which would make debugging a lot easier. But what happens if we do it that way is that instead of 1333, we now get 1349. And that's actually the result of having \\\\\x something. What we do now is we first replace the backslash, which will then lead in a backslash, an x, and something else. And in the next part, we will still match that one as a hexadecimal one. That will then lead into an underscore in our case. If we do it the way I do it now is we have 4 backslashes and an x. And what we then have is an underscore x, and that will not be matched by any regexes. So that isn't actually properly described, but that's what I found out. For part 2, we need to do the exact opposite. So instead of getting rid of the escape stuff, we now need to properly escape the string. Now, remember I built the first part myself. Gave it a couple of tries. It wasn't my first solution. My first solution didn't work because I was playing around with the regexes. So it took me 45 minutes to an hour to actually build my solution. The funny thing is, I've seen part 2 and solved it in less than a minute because there's actually one really nice thing in Swift. There's the so-called debug description. So where you see the debug description work usually is if you print arrays of string or if you just print objects. So what does that look like? If we add an escape quote into our greeting and print it, we will basically see hello escape quote playground. So the way we want it to. Now debug description actually shows the escape version. So if I run it onto the debug description, I have the version at the top, and now we have it with quotes and escape, so just what we need for our solution. So that's what I did for part 2. I just iterated over every string, calculated the difference between the debug description and the count of the string, and then with the reduce just summed it up. So the reduce is actually just a shorter form of writing that loop. You have an initial value, then for each item in input, that closure will be executed. That's basically the same as we do here. I prefer the higher order function in that case because it's clean, and then we already have the result. So that was part 2 for me. In other languages, what you also could have done is using eval and stuff like that to actually read in those lines, and then the strings will actually be properly escaped. I don't like eval. If you want to solve it quickly, that's the way to do it. I don't like eval. Swift doesn't have proper eval, and I'd rather solve it by myself. So that's why I didn't do it that way. Thanks for watching the video. I hope you learned something or at least had some fun. If you would have solved it differently, leave it in the comments, and see you on day 9.